All right, hello, my wonderful students. This is part number 2 of Foldable number 2, and this one is for a vertical compression, which we see here. So we start our parent function. The only thing different is that instead of going -2, -1, 0, 2, 1, we're starting at -4, -2, 0, 2, 4, just to show, because if you notice here, we're actually going to be multiplying the function by 1/2. And if we were to put 1, then we have a pesky fraction over here, and it's just easier. We just put numbers that divide by 2, so that when we multiply this. All right, so for this one, remember I told you that we actually multiplied the number by a function by a number. So I want to go into a little bit more detail on that. So if you notice, this is a compression, vertical compression. So that means we're going to be squishing the graph, whereas in the vertical stretch, we stretch the graph. So, and whenever this number is between 0 and 1, then it's going to be a compression. If it's a number that is greater than 1, then it's going to be a stretch. So positive and negative doesn't matter as long as the value of the number is greater than 1. It's going to be a stretch. If it's between 0 and 1 or -1 and 0 for the negative side, it's going to be a compression. So if we see this one is a compression. We can already tell, and it's also already labeled over here. So we're going to go into it. So -4, absolute value of -4. It gives us a positive 4. Positive 4 divided by 2 is the same as dividing by 2. So 4 divided by 2 is going to be 2. So we have our 1, 2, 3, 4, and then 1, 2. Absolute value of -2 becomes 2. 1/2 times 2 is 1. So we're at 2, 1. And we're already starting to see how it's going to be a little bit wider. And that's going to be our main compression. 0, absolute value of 0, 0. Anything times 0 is 0, so 1/2 times 0 is 0. 2, absolute value of 2 is 2. 1/2 times 2 is 1, so at 2 it is 1. Absolute value of 4 is 4. 1/2 times 4 is 2. So at 1, 2, 3, 4, it is 2. And then we'll go ahead and draw this here to show you guys these values, how this looks. And that's it right there. So if you can see here, we kind of compressed the graph, kind of squished it down a little bit, going from the original parent function to the function we have now.